Hey, hello all, good evening, and welcome for today's Tech Insider session. So before going into today's session, I'd like to introduce you to Globant, what Globant is all about by showing these two videos. These two videos will give you a brief insight what Globant actually does.
Now that I've lost everything to you, you say you want to start something new, and it's breaking my heart you're leaving. Baby, I'm grieving, but if you want to leave, then take good care. Hope you make a lot of nice friends out there, but just remember that a lot of bad everywhere. You know I've seen what the world can do, and it's breaking my heart in two. 'Cause I never want to see you sad, girl. Don't be a bad girl.
Reinvention moves the world forward, and that's what we do best.
Oh, baby, it's a wild world.
We are Globant, the company you probably don't know, behind many of the digital transformations you do know.
Oh, baby, it's a wild world.
Globant. Seek reinvention.
Across the world, companies have been challenged to remain in constant evolution, transform their culture and business models, rethink their customer experiences, and take advantage of new technologies such as artificial intelligence. Companies face the challenge to become augmented organizations. At Globant, we help pave the way towards this future. We work together with businesses around the world to define their way ahead and augment their capabilities to create new approaches for processes, products, and strategies. We create agile and resistant cultures where teams not only create change, but also adapt rapidly, creating exceptional experiences for millions of people. We walk along this road relying on our set of disruptors and accelerators, driven by artificial intelligence. All of this boosted by our system of studios and agile pods, operating units that foster creativity and innovation. We are a native digital company focused on helping organizations rethink themselves and find their way forward through digital and cognitive transformation. The future is now, and it belongs to augmented organizations.
Okay, thanks a lot for watching these two videos. I hope these two videos has given you a brief insight of what Globant is all about and what Globant actually does. Okay, we'll start our sessions for today, that is servers and events. So during the session, if you have any questions, queries, then you can comment in the comment box below. Okay. So to start with, so today's session, that is servers and events, is one of the simplest client server model that you can see in when we talk about event streaming, right? So you all know that nowadays applications are generating loads of data, mostly called as a big data, and it is mostly an event stream, whether it's stream from the sensors or the cameras or stock exchange data. So everything is stream based. Okay, and nowadays even client or end users requires that data to be available to them on real-time basis. Okay, so servers and event is very lightweight, open source, unidirectional way of sending such a stream of event data from server to client. Okay. So myself, Rupesh Deshmukh, I'm working as a software architect, technology leader, mentor, full stack engineer, and I have over 16 years of experience architecting, designing, and developing software applications using Java and J2EE. I do also have experience working with Scala, which is again a pure object-oriented as well as functional programming language, and some of the technology stack related to Scala. So my passion lies building a scalable, real-time, reactive application that meets the customer business needs. Okay, I am a strong practitioner of agile methodology. I support having a DevOps culture. I like to introduce automation in the projects, not just from the testing perspective, but also from the environment project provisioning and the environment patching, and obviously the functional programming, which has also got good kind of influence in Java from Java 8 perspective. So for today's session agenda, so first of all, we'll look into what server sent event is. We like to define it. It's quite a simple definition. We try to identify what all features server sent events provide. Then we will try to compare server sent events with other old technologies like Ajax WebSockets. Okay. Then I'll try to introduce SSE using Spring and React.js. That is how we can expose an SSE event endpoint or REST endpoint using Spring, and how we can use the event source API to consume that SSE event endpoint. Then I'll be demoing one file progress indicator demo, okay, using SSE. And finally, we'll be closing the session with some of the pros and cons of SSE. To start with, first of all, we'll define what the SSE is all about. So this is a very simplest of definition you can get. I got it from Wikipedia. So server sent events with a short form SSE is a server push technology enabling a client to receive automatic updates from server via HTTP connections. So I have highlighted 3 points here. That is, it is a server push technology. That is, server pushes the data towards the client automatically. Okay, and it uses the traditional HTTP connection. Okay. So some of the highlights of SSE event is SSE was introduced as part of HTML5 standard, and as part of HTML5 they have introduced an event source JavaScript API which can be used by the client to invoke or consume the SSE endpoints. And it is a server push technology, right? It is a one-way traffic that is from server to client. So server keeps on sending stream of data whenever a client requires. Okay. Then the data is sent over a traditional HTTP connection. So first of all, client request for a connection with the server, the connection is established, and the same long-lived persistent connection, HTTP connection, is used for sending the streaming of data from server to client. Then you have already worked on a lot of REST endpoints, right? Most probably REST endpoint expose JSON as its content type. Okay, so here in this case, when we develop an SSE endpoint, we use an content type which is also called as a MIA type, specifically as text slash event stream. Okay, so the server in which the SSE endpoint is exposed should be sending the data in a text slash event stream content type header. Okay, and same will be configured at the client side. So in terms of SSE events, so SSE events has been supported by most of the all modern A-grade browsers like Firefox, Chrome, Opera, Safari, Microsoft Edge. So most of the leading A-grade browsers supports SSE. Only thing is it is not being supported by Internet Explorer. But nowadays, most of the Windows operating system comes with Edge as the browser. So that is not actually a problem. Okay, so this is a short brief about SSE. So now we'll try to understand and try to compare SSE with the existing client server model that has been there quite a while and been used for client server communication, especially from event stream perspective. So first is Ajax. So Ajax, everybody knows, right? It's stands for asynchronous JavaScript and XML. That is sending of the XML data from using JavaScript from server to client. So what happens in Ajax? The client makes an XML HTTP request object, and it sends the request to the server. Once the server acknowledges it, server can send the data. So one of the overhead of this particular model is every time client requires the data, it makes a new HTTP connection and TCP handshake taken place with the client server. And we have to, along with every HTTP connections, we send the HTTP headers. So this model can have a problem with the scalability. That is, once the number of clients increases, number of HTTP connections towards the server increases. Okay. Also, it's kind of a polling mechanism. That is, client has to continuously poll to the server in order to get some kind of a data. Okay, so we cannot say this as a real-time data transfer. Okay, so that is the Ajax in a brief. So we'll now look into WebSockets. WebSockets has been widely used, especially it is used in conjunction with some of the message-driven systems like ActiveMQ or RabbitMQ for sending the push notifications from the server to client via WebSockets. So how WebSocket works is when a client wants to make a connection, the client sends a connection request to the server. Then server acknowledges that request, do the handshake, and the HTTP connection is upgraded to the WebSocket connection. So here we are using a WebSocket specific protocol, which is a WS protocol or WSS protocol. Okay. So once the connection is established, it is a bi-directional connection. Okay. It's again an open and persistent connection that happens between the client and server. But here in this case, both client can send data to the server, server can send the data to the client. So some of the highlights of WebSocket is a full duplex bidirectional communication channel, right? Yeah, it works both way. Okay, so client connects to the socket server and sends or receive messages on real time basis. Only thing is here the HTTP connection upgrade happens. That is, there is a specific protocol that is required to be used here in this case, which is WS or WSS. So if I try to compare the server sent events, with WebSockets, so server sent events is I said it's a unidirectional, right? Client when wants the data, real time data, it sends a connection request to the server. Server process the request and acknowledges the request, and once the connection is established, server will keep on sending the events to the client whenever the data is available. So it's all about one way traffic from server to the client once the connection is established. So there are other events that is possible. That is, if the server is not available or a server is too busy, there might be a timeout settings that can be configured on the client server side. So that timeout settings has to be handled on the client side. So if it is a timeout, then client has to reconnect. But one of the good thing about SSE is we don't have to add a plumbing code to do the reconnection. The event source API itself do the reconnection to the server. And finally, when the server is done with sending all kind of data to the client, server can themselves send the close signal, which can be handled at the client side. So while doing everything, the single HTTP connection is being used here, okay, to send the data, stream of the data from server to client. So when we compare SSE with WebSocket, okay, both are capable of sending, pushing the data, right? Our main aim of WebSocket and SSE is to push the stream of data from server to client. So that is achieved by both SSE and WebSocket. But the key difference is SSE is unidirectional, right, from server to client, while WebSocket is bidirectional, that is both ways. Then in SSE, we use a simple HTTP connection, right, to transport the data from server to client. But when we talk about WebSocket, it's a full duplex connection. Okay, and we require a separate protocol or upgrade of HTTP connection using the WSS protocol or WS protocol. Okay. Then in SSE, we can send only text data, that is UTF encoding it data from server to client. But in WebSocket, we can send both the binary data as well as UTF-8 text data. On the other hand, SSE has a feature of doing auto reconnection. So the event source API that was introduced in HTML5 has an internal implementation, like if there is a connection loss with the server, it auto reconnects. Also, we can have custom events in which and every event or a data can have its own ID. Okay, but there is no such feature on the WebSocket side. Okay, then there is one limitation on SSE side is the maximum. There are a limitation on maximum number of connections that a browser or client can make towards the server. I guess it's around about 6 connections per browser, but there is no such limitations in terms of WebSocket. So you will say what kind of use case SSE can be used and WebSockets can be used. So SSE can be used in the use cases like you have a stock exchange portal in which you have to show the latest stock information on real time basis. So you can use that, that is typically called as a stock ticker streaming. Or you have a Twitter feed that has to be continuously shown to the user, so you can do that. Or you can use it for sending the client notification, whether there is an severe notification of a particular hardware component. So in such cases, use cases, you can use SSE. WebSockets are typically used in the chatting application, wherein the two-way communication is desired, right? When we chat, two-person chat with each other. So uh, in that case, WebSockets is used. Also, if you want to send the stream of binary data, then obviously we have to go with a WebSocket, because SSE doesn't support binary data. Okay, so that compares and that gives thought process to the developer when to use SSE and when to use WebSocket in their web applications. So now we'll jump into how we can develop the SSE endpoint in Spring, and how we can consume SSE endpoint in React.js. So SSE endpoints, developing SSE endpoint is supported by all the major frameworks, Java frameworks right now. So you can create a SSE endpoint using Spring Webflux. You can create it in Quarkus. You can create it in Akash HTTP. You can create it in Micronaut. So all the leading microservices framework provides classes or libraries to expose the SSE endpoint. So when we talk about a client side, so consider we are developing using React.js. So like I mentioned, that event source is a JavaScript API that was introduced in HTML5 standard in order to support or consume the SSE endpoint. So it's quite a simple syntax, that is, we create a new instance of event source and we provide the endpoint URL of the SSE. Okay, so then once we establish the connection, we can add different kind of listeners, okay, on the event source. So this particular event listener is for consuming or listening to the custom events provided by the server. So like you can see, it is adding a listener for GUI ID, that is, server generates a GUI ID for each client, and the client subscribe to that GUI ID and store it somewhere. And then once the GUI ID, clients get that GUI ID, whatever value against that particular GUI ID, it tries to consume and parse it. Okay, so this is the second step on the client side, that is configuring the listeners. Then there are other event handlers that is provided by event source API, that is on open. That is, whenever an connection is open with the server, this particular event handler is invoked. So you can do some kind of initialization logic on the client side, or you can just do some kind of a login, that is, connection has been established. Then finally there is another event handler which we can configure on the client side, is that is on error. Okay, so if there are any error events sent by the server, this event handler will be called upon, and the event source has different states, right, in which we can see what kind of event state it is. Okay, so if it is a closed event, then whatever plumbing code or whatever the cleanup activities you have to do, you can write in this particular event handler. Okay, so earlier we saw that we had added an event listener, okay, so for consuming the custom messages, but we can also have another event handler called as dot on message. Okay, so which is another event handler to handle the traditional data events within the SSE. Okay, so this is a very a simple piece of code that we have to do on the client side in order to manage the SSE endpoint. So when we talk about backend side, in Spring, Spring has provided a class called as SSE emitter, okay, which can be used to send the or raise the SSE events. So you can see that it is a simple method which returns SSE emitter as a response body, and it is an get endpoint. Okay, and the endpoint name is slash progress. Okay, so what here we are doing is we are creating an SSE emitter instance, Okay, we are creating an UUID, okay, GUI ID for each client whenever this endpoint is invoked, and it is just sending that GUI ID to the connection request. Okay, and on the same time it is adding some hooks, that is on completion hook and on the timeout hook on the SSE emitter. That is when the completion signal is raised, SSE will remove that particular client from the server side, and when there are timeout, the SSE will remove that client ID from the server side. So that is the first thing, that is expose an SSE endpoint using SSE emitter. Okay, so once the connection is established and this particular SSE endpoint is configured with the client, then the simple way of sending notification to the client is using dot send method. Okay, in which we just specify the name of the event. That is, here in the case we are passing the GUI ID which was generated for that particular client, and the actual data. So the data can be as I said, it's a text data, it can also be a stringified JSON data. Okay, then besides the normal sending of the events, we can also send the error events. Okay, using the complete with error, that is if there are any exceptions while processing the server side request, so a server can also raise the error exceptions via SSE emitter. So that was basically a three-step process wherein we how we can define an SSE endpoint using SSE emitter on the server side, and then how we can send the events to the client using SSE emitter. Now we'll look into a live demo, okay, in which I have exposed one SSE endpoint and I have created a simple UI. So UI is all about it's a simple file upload functionality. Okay, everybody knows, right? If there are huge files, a user can select a file and click upload button. But in order to have a user friendly UI, we have to indicate show some kind of indicator key, how much file percentage has been uploaded. So that can be achieved using SSE. So in this particular example, we have exposed two endpoint. One endpoint is basically to actually upload the file, and one endpoint to provide a progress of file upload to the client. Okay, so going back to my application, so this is my application. Okay, so I'll just open a network tab here. Okay, now I'll choose a file. Probably first I'll have to create a file. Yeah, so it's a random file. So just a simple text file with some random data. Okay, and then I'll try to upload that file. So as soon as when I click upload button, so you can see this progress endpoint is shown. Okay, and you can see the event streaming data, that is the percentage of a file upload has been sent from server to the client, and at the same time it is reflected in the progress indicator on the client side. So 10, 20, 30, this is actually the upload percentage of the file. So once the file is 100% uploaded, you can see the file upload success message is shown on the client side. Okay, so now we'll do a deep dive into the actual code. Okay, so this is my backend side, that is a Spring controller, in which first of all I have exposed one API to upload a file. Okay. So this is a post REST API, okay, in which it takes the multi-part file as an input and the GUI ID of that particular client that was generated. So what it does is basically it internally calls this particular file upload service to read that file, okay, and send the percentage notification to the server. Okay, so you can see this is the service that is invoked. It's a simple logic to read the file using input stream buffer reader, traditional file IO. Okay, here there is some kind of a calculation is done to calculate the percentage of file based on the reading. Okay, so this line is we should look into is, that is, we using the SSE emitter, I am sending for that particular client, I am sending the percentage. So percentage is nothing but simple value that has been calculated in the earlier logic. Okay, forget about this logic, just consider that here I am regularly sending the file upload percentage to the client, which is identified using this GUI ID. And finally, once the entire file is completed, I am sending the 100% file upload is completed. Okay, and this entire block I have added it in the try catch, in which if there are any exceptions, then send the exception directly using this method, complete with error. So this is the service. And then besides the file upload API, I also have an SSE endpoint, which I also shown in the previous PPT slide, in which I am exposing an SSE event endpoint, which is of type HTTP GET method, and it is returning SSE emitter as an response body. So that SSE emitter will have the information like GUI ID that was generated for that particular client when this endpoint is invoked. And we are adding the hooks like the on completion hook and on timeout hook. That is, whenever those hooks are invoked, the particular client has been removed on the server side, because we are maintaining the GUI IDs of all the clients as this concurrent hash map to avoid the threading issues. Okay, so this is the simplest piece of code that we require to develop for exposing the SSE endpoint. Then from the client side, again, it's quite simple. So as I mentioned, first of all, we have to create an instance of event source API that was introduced in HTML5 standard, and we have to specify the endpoint of SSE. Okay, once yeah, we create that instance, we can define the hooks. Okay, so there can be different hooks like add list anti-event listener is an hook which can be used to listen to the custom events like GUI ID event and actual file percentage event. Then we have on error event handler, that is whenever there is an error raised by the server, we can handle in this event handler. Then on open, that is whenever there is a connection open on the from a client to server, then this method can be invoked. Okay, then there is another event handler called as on message, which can be used for traditional event stream data. Okay, so here you can see that first of all, client invokes the endpoint, right? Try to make a connection to the server, that is a slash progress endpoint, and the server responds back with a GUI ID. That GUI ID is then used by the client to get the remaining data which is mapped to that particular GUI ID. So which is also visible in this particular example. So you can see first the server sends a GUI ID, and then using this GUI ID it is sending all the percentage data to the client. And then finally we have an open event handler, that is whenever the connection is open, it is just printing. So this is simple React.js application in which you can see this is a single page in which we have use a file upload widget, and it is just showing the file, the percentage that has been sent to the from server to client. So I hope this particular example has given you a good insight that how we can expose an SSA endpoint in Spring, and how it can be consumed using event source API on the React.js side. So finally, to conclude, I like to provide you the details about what kind of pros or cons we can have, or what kind of advantage or disadvantage we can have when we talk about SSE. So when we talk about our pros, it's very simple, very lightweight. Okay, it doesn't require any kind of special changes on the web server side or web proxy side. Okay, because it is based on a simple HTTP connection. Okay, we can have our own custom events, okay, which can be identified using event ID. The data can be of a JSON format, okay, but it should be a simple UTF-8 encoding data. We cannot have a binary data. And then the SSE event can also be secured by using the traditional authentication mechanism. Like right now, the demo that I have shown, it was not a secured endpoint, but we can also make it secure by having the authentication details on it. Then in terms of disadvantage, I will not call it as disadvantage, but some limitations. uh, SSE is a unidirectional communication channel, right? This is how it was designed to, right? They wanted to make it very lightweight, so it is unidirectional, that is one way communication from server to client. It is being supported by most of the modern browsers, but it is not currently supported by Internet Explorer. Okay, but as I mentioned earlier, I in most of the latest Windows operating system, there is an Edge browser which people are using, which is much better than I. So that is not a limitation, but WebSockets do support is provided in I. Okay, as compared to SSC. Then SSC requires cross origin enabled header access header enabled on the server side, so that can result into a vulnerable XSS attack, so that has to be separately handled as compared to WebSockets. Okay, and this point I have already covered, right? SSC only handles the text, that is UTF-8 data. It doesn't handle the binary data like array buffers, blocks, but which is supported by WebSockets. Okay, so that's all I have to cover about SSE. I hope you liked my session. If you have any queries, again, you can always comment into the comment box below, and you can reach me out via those comments. So thanks all.